Welcome back everyone. In the last video, we explored named volumes and saw how they help solve a big problem, data loss when containers are deleted. Today, we are going deeper into Docker storage, which is all about how Docker stores and manages your data behind the scenes. By default, containers are ephemeral, which means temporary. This means when you delete a container, everything inside it is gone forever. That's why Docker gives us 3 storage options to keep data safe. Named volumes, which we already covered in our last video. Anonymous volumes, which Docker creates automatically. And bind mounts, which give us complete control and real-time sync with our local machine. In this part, we will focus on anonymous volumes and bind mounts. Let's start with anonymous volumes. These are volumes that Docker automatically creates whenever it sees a path inside a container that needs persistence, but you didn't specify a name. We will first create our own simple Docker image so we can clearly see how anonymous volumes work step by step. Once we understand the basics, we will move to a real world example using a predefined image like MySQL. Let's see this in action. I am here in Visual Studio Code and I have already created a folder for today's demo. Inside this folder, I have created a simple Docker file. Let me walk you through it line by line. We are starting with Alpine 3.20. Alpine Linux is a very lightweight base image. And next I have set the working directory to /data. If this folder doesn't exist, Docker will create it automatically inside the container. Think of it like saying, "Hey Docker, go into this folder before running any commands or copying files." Next, here's the key line for today, the volume instruction. It tells Docker that this folder /data should be persisted outside the container using a volume. This means any files written to /data won't live only inside the container. Even if the container is deleted, the data will still be safe in the volume. Finally, the CMD instruction. This tells Docker what to run when the container starts. Let's break this down carefully. sh-c runs the following string as a shell command, and echo anonymous volume demo. This creates a new file named file.txt. Inside the /data folder and writes this message into it. And is a logical AND, meaning the next command only runs if the previous one succeeded. Sleep 300. It pauses the container for 5 minutes, so we have time to inspect it. So that's our Docker file. Now let's build the image. Docker build -t. I am giving the name as anon demo dot. Let's check Docker images. anon demo. Let's go to Docker desktop. We can see the anon demo created with the latest tag. Let's go back here. Let me clear the screen. Docker images. Let's run the container. Docker run -d detach mode --name. Let's give the name as anon container, and we need to pass the image name. Copy this. Let's quickly check that our container is up and running. Let's do docker ps. So the container is up and running, and to list all volumes we need to use the command docker volume ls. Here we can see a randomly generated volume name. This is an anonymous volume created automatically by Docker because of the volume instruction in our Docker file. Let me also show you this visually in Docker desktop. Under volumes, you will see this exact random volume listed. This is where our containers /data folder is being persisted. Let's check what's inside the container. Docker exec -it, and we need to pass the container name. Give sh. Now we are inside the container. Let's do ls. In the /data folder, we can see the file created by our cmd instruction. Let's do cat command. And if you open it, it contains the text we wrote earlier, anonymous volume demo. Let me exit the container. Let me clear the screen. Let's inspect. We can inspect by using docker inspect command. Docker inspect and pass the container name. If you see the mounts section, type as volume and name the anonymous volume name and the source and the destination. Now let's delete the container completely and we will check. Let me clear the screen. Let's delete the container. Docker rm -f. I'm passing the container name. Let's check volume again. Docker volume ls. Notice something important. Even though the container is gone, the anonymous volume still exists. That's because volumes are managed separately from containers. This ensures your data remains safe even if the container itself is deleted. Let's open the volume using a temporary helper container. I'll do docker run -rm flag and -v. Usually we will pass the named volume, the volume name colon and the container path. But here the volume name is this random string. Let's copy this. I am passing this one colon /data, the container path, and I am giving Alpine as the helper container and do ls/data. Here I am mounting the anonymous volume inside a temporary Alpine container. The -rm flag automatically deletes this helper container after it finishes, and the -v flag attaches the anonymous volume at /data inside this helper container. And finally, the ls/data command lists the files inside the volume. So we can see the output here, file.txt. Let's read the file inside the anonymous volume. Docker run -rm -v and pass this anonymous volume colon /data, the path inside the container, and Alpine. And to view the contents of the file, we need to use cat command, cat /data /file.txt. We can see anonymous volume demo. This confirms that the file our original container created is still safely stored in the anonymous volume even though the original container is no longer running. Here anonymous volume don't have a human readable name. So you must copy and paste the random name to inspect them. And when you no longer need the volume, you can delete it by using docker volume prune command. Let's try that. Let me clear the screen. Docker volume ls and docker volume prune. It's asking for confirmation. Give y and continue. See deleted volumes, total reclaimed space. Over time, anonymous volumes can pile up, so we can use this docker volume prune command to delete all unused volumes and free up disk space. So let me clear the screen, and now let's see another way Docker creates anonymous volumes. This time I will comment out the volume line in the Docker file. Let me save this, and instead of this we will explicitly use the -v flag when running the container, but without specifying a volume name. Let's try that. Let's rebuild the image. Docker build -t. I'm giving the name as anon demo dot, and now we have built the image using the updated Docker file. Let's do Docker run. Let me clear the screen. Docker run -d detach mode -name. I'm giving the name like anon container 2, and I'll give like -v, but I don't specify any name here. I'll simply pass /data, the path inside the container, and we need to pass the image name. Let's do that. See, the container is up and running. Here I am using the -v flag to mount /data. Because I didn't specify a name before the colon, Docker automatically creates another anonymous volume for us. Let's verify that. Docker volume ls. See, once again, here's a randomly generated volume name, and this is the second way that we can check the anonymous volumes. Let's go to the volumes section again in the Docker desktop. You can see here Docker has created an anonymous volume in this second way as well. Let's do some cleanup operations here. Let's delete the container. Docker rm -f is anon container 2. And we can prune unused volumes. So Docker volume prune. It's asking for confirmation. Give y and continue. See, deleted volumes and total reclaimed space. When you are done, you can remove unused anonymous volumes with Docker volume prune to free up disk space. So to recap, there are two ways anonymous volumes can be created. One is automatically when a Docker file contains a volume instruction, and manually when you run a container with -v but don't specify a volume name. But why does Docker even bother creating these volumes for us? Let's explore why anonymous volumes exist and why they are so important. Anonymous volumes are there to protect your important data by default. Many official images like MySQL, Redis, RabbitMQ and Jenkins and so on, they come with pre-configured to automatically create volumes. This ensures beginners don't accidentally lose critical data when they restart or replace containers. Let's take a quick look at Docker Hub to see how this works in real world images. Let's go to Docker Hub and we can search for images like MySQL. I'm clicking on the Docker official images MySQL artifact, and let's go to the latest tag. If you see the Docker file here, you can check volume instruction /var/lib/MySQL. So MySQL declared a volume instruction in the Docker file. Let's check Redis. I'm clicking on the artifact, and if you go to latest or even any version is fine. So you can notice here volume instruction /data. So both MySQL and Redis declare a volume instruction in their Docker files. So this tells Docker, hey, keep this folder persistent even if the container is deleted. Let's do some hands-on. Let me clear the screen and now let's run these images ourselves and see what happens. Docker run -d detach mode --name. I am giving the name as demo MySQL, and we need to pass the image name, and image name is MySQL. I am running the MySQL image. I didn't specify any -v or volume name here. Docker will automatically create an anonymous volume. Let's check that. Let's check the running container. Let's do Docker volume ls to list the volumes. Here the random name Docker gave to the anonymous volume it just created. Let's check that. Let's inspect. Let me clear the screen. Docker inspect. Let's pass the container name. can see here under mounts section, type as volume and name the anonymous volume, the Docker automatically created for this /var/lib/MySQL. Let's try Redis. Let me clear the screen. Let's do docker run. -d detach mode and -- name. Let's give the name as demo Redis, and we need to pass the image name, and that's Redis. Let's inspect docker inspect demo Redis. If you see here under mounts section, type as volume and name anonymous volume, and the destination is /data. So we can see the /data folder mapped. So anonymous volumes are not just for databases or caches. Many other types of servers and tools use them. Let's verify that in the Docker Hub. Let's go back and let's search RabbitMQ. I'm clicking on the artifact, and if you go to any Docker file, you can see the volume instruction here, and they are passing an environmental variable. Let's search this. So this one. So RabbitMQ data directory variable lib RabbitMQ. So this is the path it is using. For our volume instruction. Let's check some other images. Let's check Jenkins, the CI/CD tool, and this is the Jenkins official Docker image, and I'm clicking on the artifact, and let's click on the latest, and you can see the Docker file here, and see volume instruction /var/Jenkins home. Like this we can try some other too, like let's check one more. Joomla, say CMS tool. I am clicking on this Docker official images, clicking on the artifact. Let's go to any version. and you can verify the Docker file here. See the volume instruction /var/www/html. So if you go back here, so Joomla is a free and open source content management system for publishing web content. It is built on a model view controller web application framework. So all these official images, MySQL, Redis, Jenkins, even WordPress and so on, use volumes to make sure your important data survives even if you delete or upgrade the container. Let's check. WordPress, and if you go to the any version, you can see the volume instruction. So without a volume instruction, all data would be gone forever. So why anonymous volumes are helpful? Because they are like Docker's safety net. They are great for beginners because you don't have to configure anything. Docker automatically protects your data behind the scenes. But in production, when you move to production environments, you need more control over your data. So we need to follow some best practices, like use named volumes. Give the volume a name so you know what it's for. For example, if it's for MySQL, you give the volume name as MySQL_data, like that. And back up your data. So treat volumes like hard drives. Make regular backups of database files and configs. And clean up old unused anonymous volumes. So over time, unused volumes pile up and waste space. So run Docker volume prune to safely delete them, and inspect containers regularly. We can use the command docker inspect to check where data is stored. Even we can go here, inspect, and check mounts. Type as volume name and the destination. So anonymous volumes are great when Docker automatically handles where the data is stored and you don't have to think about it. But sometimes as a developer, you might want to work on files directly on your computer and see those changes immediately inside the container. For those, we use bind mounts, and let's see how they work next. So anonymous volumes, Docker takes care of everything, and bind mounts, you control files directly. Let's explore that. So far, we have seen how Docker automatically creates anonymous volumes to protect important data. But what if you, as a developer, want to directly work on files on your machine and instantly see those changes inside a container? That's exactly where bind mounts come in. Here I have a simple index.html file in my local folder. This is just a basic web page that says hello from bind mount. I would like to use Nginx as a helper container here. Let's do docker run -d detach mode name. Let's give the name as test -p port mapping. I'm giving like 8088 as the host port and the container port as 80, and -v volume, and here I would like to pass my present working directory as the host path and container path as usr share nginx html, and we need to pass the image name as nginx. Let's check docker ps-a. So the container is up and running and listening on port 80, and the host port is 8088. Let's check that in browser 8088. We can see hello from BindMount. So here -d detach mode --name. I gave the name as test to easily identify this container, and -p port mapping. I'm mapping port 8088 on my computer to port 80 inside the container, and -v this $pwd :usr share nginx html. So here on the left side, $pwd means my current folder on my computer, and right side is where nginx expects to find website files. So with this setup, Docker is directly linking my local folder to the container. This means any changes I make here will show up live inside the container. We verified the browser and we saw hello from BindMount. Let's check the live sync local to container. Let's update this index.html. I will edit this h1 tag. I'll give like updated text hello Docker. Let's save this and let's refresh the browser. You can see updated text hello Docker. Now verify inside the container. Docker exec -it interactive mode test sh. Now we are inside the container. ls-l /usr share nginx html. So we have index.html present, and let's do cat command cat /usr share nginx html /index.html. You can see here hello from BindMount, updated text hello Docker. So these both matched, right? Now let's do reverse sync, like container to local. Let me exit this and clear the screen. From inside the container, we will try to append a line Let's do that. Docker exec -it test sh, and we'll give sh-c. We'll pass echo statement, echo. I'm giving like a p tag, like a paragraph tag, added from container /p and we'll write to /usr share nginx html /index.html. We'll try this. Okay, we need to do a double quote here. Okay, now let's refresh the browser. See, added from container. Let's go back. So even if you notice here, the local index.html, this line is added from container. So bind mounts link a folder on your computer directly to a folder inside the container. Any changes made locally or inside the container are synced instantly both ways. This makes bind mounts perfect for development, where you need live updates. So bind mounts are real-time, two-way sync, and this is best for development environments. So let's do cleanup. Docker vs-a, docker rm-f. I'm deleting the container. So that's it for bind mounts. Let's do a visual recap. Docker gives us 3 ways to manage data: named volumes, anonymous volumes, and bind mounts. Named volumes, these are best for managing persistent data. Anonymous volumes, created automatically by Docker when no name is provided. Bind mounts, directly connect your local files to containers. Official Docker images with predefined volumes. Many popular Docker images come with pre-configured anonymous volumes to keep critical data safe by default. Docker bind mounts, live sync, named volume versus bind mount. So named volumes, these are safer for production, easier to backup, and fully managed by Docker. Bind mounts are ideal for development, giving complete control and real-time sync. So bind mounts give you a live connection, two-way sync, anonymous volumes are automatically managed by Docker, perfect for official images like MySQL or Redis to protect your data. Bind mounts, on the other hand, give developers live connections, so changes in your local files instantly appear inside containers. To wrap up, use named volumes for production and long-term data safety, and use bind mounts for development and quick testing, and be aware of anonymous volumes, especially when using official images. Thanks for watching. If you found this video helpful, please like, share and subscribe, and leave your comments or suggestions in the comments, and let's catch up in the next tutorial. See you next time.